Hello students, this video is designed to help with the mini-mock cycle pretest 1. As you know, we're in the mini-mock cycle. We're doing small targeted tests in class and trying to figure out what you know about the following topics. We're going to be talking about graphing, absolute value, axis of symmetry, percentages, and roots. If you did not get this document in class, you'll be able to take a look at it on the video, so no worries about that. Let's jump into that first short answer question. That's question number 15. It talks about solving the following system of equations graphically and stating the coordinates of the solution. You should notice that one of these equations is already in so-called slope-intercept form. That's the second equation. The second equation is this one here. And you already have the slope, which is -2, and you already have the y-intercept, which is -1. So we're able to graph that fairly easily. We take that y-intercept, which is -1, and we're going to plot that on our y-axis here, very accurately, I might add. And that slope, which is -2, means I'm going to go from that point down 2 over 1. So I'm starting at this point here, and I'm going down 2 over 1. That's my next point. Down 2 over 1. Here's my next point. And I can do the same thing going backwards. I can go up 2 and over to the left 1. So there's my next point there. And I continue on this process and graph the straight line, and it looks something like this. So you can see the entire equation graphed, and I've labeled it with y equals -2x minus 1, which is the equation. The first equation, though, is not already graphed into slope-intercept form, so what we need to do is solve it first, and then we can graph it very easily. So we'll take the equation, we'll write it here on the side of the paper here. We got 4x minus 2y equals 10. And we're going to try to solve this by isolating the y, getting the y term by itself. So we're going to subtract 4x from both sides first. And over here. And we get -4x plus 10 on that side. And on the left-hand side, it's -2y. That's the only thing that's left over there, -2y. And there's an equal sign still in between. I need to get y by itself, which means I'm dividing both sides by -2. So I'm going to go ahead and write that down. Divide by -2. Divide by -2. And on my left-hand side, I just have y. On my right-hand side, -4 divided by -2, that's going to give us a +2. So that's y equals 2x. And then +10 divided by -2 minus 5. So that graph is going to look sort of similar to this graph. It's got a similar slope, except it's positive. And its y-intercept is negative, but not -1, -5. So I'll go down to -5 here. So I'll put the y-intercept at -5. This is at -6. Let's get -5 in there. We're using red. So -5, -1, 2, 3, 4, 5. Great. And our slope is +2, which means I'm going up 1 over 2. That's my first point. Up 1 over 2. My next point, up 1 over 2. Same thing. And I can do the same thing backwards. You should by now be very familiar with how to graph lines, so please try to practice this skill at home. All right, as you can see, I've graphed y equals 2x minus 5. I'm basically done with this problem, but make sure that you understand that it's asking for you to state the coordinates. This is the big answer that we're looking for. So we need to state the coordinates where they intersect each other. Well, it looks like they intersect each other at this point, which is +1, -3. We can identify that as the solution point, but we must also state the solution. The solution is +1 and -3. There's your answer. If you did not identify that this was the solution at +1, -3, you only got 1 out of 2 points. All right, moving on to question number 16. Question number 16 asks us about the percentage of ninth graders that have more than one sibling. Looking at the table, I can see on this table that these ninth graders have more than one sibling, and these ninth graders have more than one sibling. These ninth graders have one sibling, so they don't count. So 28 and 15, if I add those together, I get 43. So that's 43 is my first number. That number of ninth graders have more than one sibling. But I'm looking for the percentage of ninth graders, which means I have to take my total and put that in the denominator. That's the total number of ninth graders. So 43 divided by 172. I know that 43 over 172 is something that I can put into my calculator. And when I do, it gives me 0.25. That answer is in decimal form. If we change this to percentage form, it becomes 25%. So the answer is 25% of ninth graders have more than one sibling. Very straightforward question. My next problem, which is problem number 17, asks me to graph and label these equations. So I'm going to go ahead and annotate that, graph and label the equations. And the next thing it asks me to do is explain how changing the coefficient of absolute value affects the graph. Let's do the graphing first. I know that my calculator can graph these, so I'll pull out the calculator. In my calculator, I'm going to put in y equals absolute value of x. I go to my y equals menu, and absolute value is in the math menu. So I'm going to go math. I'm looking for numbers, so I go over to numbers. And ABS stands for absolute value. In your calculator, absolute value is going to show up as those straight vertical lines, maybe, if it's a newer calculator, or if it's an older calculator like this one, it'll look like ABS parentheses. All I got to do is put in the X there, and then looking at the graph, it looks like that. It's a V-shaped graph. Absolute value looks like a V-shaped graph. How about that? If I graph this, well, in order to graph this, I go to my second table function, 0, 0, 1, 1, 2, 2, looks very straightforward, and then in the negatives, negative 1, 1, negative 2, 2, etc. One of the things that I have to keep in mind that it gives me an interval in this problem, and the interval is from negative 3 up until 3. So that means I'm only graphing the x values from negative 3 to 3. So if you look on the calculator screen here, all the x values are from negative 3 to 3, so I'm only graphing the ones that I see here. And then at the ends, I'm going to put a closed circle. So I'll slide the calculator over a little bit, and I'll show you what this graph looks like. So there you have it. Here's y equals absolute value of x. The next thing it asks me to do is graph y equals 3 absolute value of x, or 3 times the absolute value of x. So in my calculator, I'm going to change this to, say, times 3. Neat trick in the calculator, I press second INS. I'm going to insert a 3 here. And I'm also going to insert a times here. So 3 times absolute value of x, that's what this is. If I look at my graph, it looks a little bit different. Notice how it looks a little bit steeper, like the slope is different. If I go to my graph, you can see that these y values have all changed. So I'm going to graph that next. And you can see here that this is y equals 3 times the absolute value of x. Looks a lot different, looks much steeper, but I'm still using the same interval. I'm stopping at negative 3 and positive 3 on the x-axis. Now I have to explain how changing the coefficient of the absolute value affects the graph. Well, it looks like it's making the graph more steep. It's changing the slope. It is elongating or stretching the graph. All of these are acceptable answers. I'm going to write down a couple of acceptable answers for you here for you to look at. All right, many of these answers would be acceptable. As the coefficient changes from 1 to 3, the graph becomes more steep. Also changes the slope. Also is stretched vertically compared to y equals absolute value of x. All of these answers are appropriate. We're just looking for the idea that the graph of 3 absolute value of x has been stretched or changed in that way. Take a look at question number 18. That's the last question on this mini-mock. It talks about this quadratic equation, and it says find the equation of the axis of symmetry and the coordinates of the vertex algebraically. Here's the method to do it. You need to remember a very simple formula. This handy formula, x equals negative b over 2a, that's going to give you the axis of symmetry. So when I look at this equation, I have an a value, a b value, and a c value. So we're going to label those values as a, b, and c. Now once we have these values figured out, we're going to use the b value and the a value to try to find the axis of symmetry. We'll simply substitute them in. So here you can see we took the b value, which is negative 4. We substituted it in for b. Notice that it's already negative from the negative b over here. So negative 4 is going to become positive 4. The denominator is going to be 2 times 2, which, as you know, is 4. So my equation, my x is equal to 4 over 4, is going to become very simple. So the axis of symmetry is x equals 1. That's the equation of the axis of symmetry. That's the first part of what it asks for, the axis of symmetry, but it also asks for the coordinates of the vertex. In order to find the vertex, it's actually fairly straightforward. We know the axis of symmetry cuts through the vertex. If I had to draw it as a picture, the parabola might look something like this. It might have a vertex down here. Here's your vertex. The axis of symmetry actually runs directly through, if I could draw that very clearly I would, the axis of symmetry runs directly through that vertex. So what we need is the coordinates of the vertex And it's going to be based on the fact that this axis of symmetry is the x value of the vertex. So I know that my vertex, if I had to label the x value, would be 1 comma something. So as I said, I already have the x value of my vertex. All I need is the y value. In order to get the y value, I'm going to take my x value, which is 1, and substitute it into the equation. Once I substitute 1 into here and 1 into here for x, I'm going to solve it to find f of x, which is also known as y. So my f of x is going to be, in this case, f of 1. My 2x squared is going to say 2 times 1 squared, again, because I know the x value here is the x value of my vertex. I need to find my y value now. Minus 4 times 1 plus 5. The next step is I'm going to follow my order of operations. 1 squared is equal to 1. So I got 2 times 1 minus 4 times 1 plus 5. Next in order of operations comes multiply. 2 times 1 is 2. Negative 4 times 1 is negative 4. And 5 stays the same. Now I'm going to combine like terms. 2 minus 4 is negative 2 plus 5 is 3. So my y value, my f of 1, is equal to 3, which means my vertex is 1 comma 3. Simple as that. That's how to find the axis of symmetry and the vertex. Now we're going to move on to finding the roots. The next step says to find the roots of the parabola algebraically. If you had taken this equation and put it into your calculator, you would have seen something very interesting. So here's the equation here. If I look at the graph, I can see where the vertex is. That's the vertex. I can also see that this equation, this parabola, does not intersect the x-axis at all, which means it doesn't have any roots. So I could just say there are no roots or the roots are imaginary, but that's not algebraically. So I'm going to show you how to verify this algebraically. So I know that there are many methods to finding the roots, but the method that always works is using the quadratic formula. So I'm going to use the quadratic formula on this quadratic equation to try to prove that there are no roots or that there are imaginary roots. So here is the formula, the quadratic formula, that's going to give me the roots. The first thing I'm going to start doing is substituting the values in. So I know that x is equal to negative b, and I know the b value is negative 4, so I'm going to say negative 4, plus or minus the square root of, and this is going to be a long square root. B squared is negative 4 quantity squared minus 4 times a, and I know that a is 2, and I also know that c is 5, so I'll plug that in there. Substitute, I'm going to divide that by 2 times a, and that means 2 times the a value, which is 2. And remember, I'm getting these a, b, and c values from up here. We found the a, b, and c values a long time ago. So now that I've first written this out, I know that my next step is to take everything inside this square root and simplify it in the calculator without putting the square root, but just putting all the numbers. So that's the next thing I'm going to do. It looks like this. I'll bring up my calculator here, and according to the calculator, negative 4 squared, keep in mind that we need to use these parentheses here. Negative 4 squared minus 4 times 2 times 5, that's going to give me negative 24. Alarm bells should be going off in your head right now. Oh no, it's a negative. So the next thing I'm going to write is this, equal to, I know negative times negative 4 is positive 4. My plus or minus stays here. The square root is of a negative number, negative 24, divided by 2 times 2, which is 4. I'm not going to continue solving this. I can stop right here because I know that a negative square root, any negative square root, means it's an imaginary number. So if this is an imaginary number, we can say imaginary or no roots. All right. So what we've talked about so far in this video is we talked about finding the roots, finding the axis of symmetry, graphing an absolute value equation. We also talked about finding the graphs of two linear equations and finding the solution. And we also talked about finding percentages. Hopefully this was helpful to you. Good luck studying.